Let's start with the first question. Sin x is equals to minus 3 by 5, where x belongs to pi to 3 pi by 2. That means here they've told us that our x is lying in the third quadrant. So they've told us which quadrant our x is lying in. And we know our sin x is minus 3 by 5. So which is basically perpendicular by hypotenuse. So we know the values of our perpendicular, we know the value of our hypotenuse. So what would our base become? Simply h square is equal to p square plus b square. So our base would become 4. And since our base is 4, how can I write out my cos x? My cos x would become base by hypotenuse. So it would become 4 by 5. What would my tan x become? My tan x would be written as perpendicular by base. So it would become 3 by 5. Sorry, 3 by 4. Now, since it is in the third quadrant, in my third quadrant, as per the cast rule, my tan used to be always positive. Apart from my tan, each and everything used to be negative. So my cos x, this would be negative value. However, my tan x would still remain positive. So now what has been asked to us in the question? We need to find out the value of 80 tan square x minus cos x. So simply this would become 80 times of tan square x. This is 3 by 4, so this would become 9 by 16 minus cos x, so this would become 4 by 5. So if I solve this, I can take 16 5s are 80 as the LCM. So I would have 45 plus 64. This would give me 109 as the answer. So this is my answer. So again, a very simple question, a question from the trigonometric ratios. That was the first thing that we studied in this chapter. Simply, you just needed to identify the quadrant they have given us, and based on that quadrant, your cos would be negative, your tan would be positive, and then simply substitute the values. Let's look at the next question. If theta belongs to 0 to pi by 4. So here, now again, they've told us that it lies in the first quadrant, and they've given us a very small portion of the first quadrant, half of the first quadrant basically, from 0 to pi by 4. And what have they asked us? The value of cos theta. So what we'll do is, first we'll try to convert this equation into a single trigonometric function equation. So what we can do is, we can do 4 cos theta minus 1 is equals to 3 sin theta. I'll put it in this way. And now I'll square both these sides. Since I need to find out the value of cos theta, so I'll try to convert my sine into cos as well. So I'll square both these sides. We will have 16 cos square theta plus 1 minus 8 cos theta. And this would be equal to 9 times of sine square theta. Now how can I write down my sine square theta? It can be written as 1 minus cos square theta. So this would become 16 cos square theta plus 1 minus 8 cos theta is equals to 9 minus 9 cos square theta. So from here, what do I get? 16 plus 9, this would make it 25 cos square theta minus 8 cos theta. Minus 8 is equals to 0. So this is the quadratic that I'm getting. Now solving this quadratic, keeping my cos theta as t. So what would I get? This would be minus b plus minus root under b square minus 4ac 32 into 25 divided by 50. This is what I'm going to get. So if I solve this further, I would have 4 plus minus 2 root under 54, or this would become 6 root 6 upon 25. So this is what I'm getting after solving the entire equation. Now cos theta is this. Now which is the value that I'm going to be taking, either plus or minus? Now if you look at the condition that they've given us, it is lying from 0 to pi by 4 only. That means, of course, I would only be able to take the positive value, because if I take the negative value, I would have a negative sign here, because minus 6 root 6 is obviously greater than 4. My minus 6 root 6 would be greater than 4. That means if I sum these two together, I would have a negative value, which cannot be taken. So therefore, as per the conditions, my cos theta would be simply equals to 4 plus 6 root 6 by 25. And this is my answer. Now, of course, let's say if in the question they would have told us that you need to rationalize the answer further. Simply you could have multiplied 4 minus 6 root 6 in the numerator and denominator and rationalize your answer. So we'll leave it up to here because this is what they've asked us. So this is how you find out your cos theta. Always remember in trigonometric functions or equations, keep in mind the domain they've given us, and also remember the range and domain of the function that you already know. Based on that, try to propose whatever answers you are getting. Let's look at this question. The number of solutions of the equation e to the power sin x minus 2 e to the power minus sin x is equals to 2. So again, simply what I'll do is I'll assume my e to the power sin x to be t. And one thing, since there has been no domain, nothing has been mentioned to us, one thing that we know is that e to the power x, how does its graph look like? It is going to be in this way. That means e to the power x is always greater than 0, right? That means from here I can say that my t would always be greater than 0. So this is the equation that we built in from our side. Now let us solve the equation. Let us substitute e to the power sin x with t and form a quadratic equation. So this would become t minus 2 by t is equals to 2. So we would have t square minus 2t minus 2 is equals to 0. So upon solving this, I would have t is equals to minus b plus minus root under b square 4 plus 8, and below I would have 2a. So upon solving this, I would get 1 plus minus root 3. Now of course I know that my t always has to be greater than 0, and I know root 3's value is 1.732, something like that. So since it is greater than 1, that means I cannot take the value 1 minus root 3. 1 minus root 3 would become negative, and t cannot be negative anywhere. So that means the only value that is possible is t is equals to 1 plus root 3. That means from here what do I get? That my e to the power sin x, this is equals to 1 plus root 3. Now if I was to solve this further, of course they've asked us the number of solutions, so we need to find out the number of x that would satisfy this equation. So from here what I'll do is I'll take ln both these sides. So I would have sin x left here, and this would become ln of 1 plus root 3. Now if you all know a little bit about the logarithmic graphs, which looks like this, and if my base is and my base is e, at the e, what is the value that I generally get? I get 1, right? And here if I look at this value, my e is generally 2 point something. Here I'm getting 1 plus root 3. That means the value would be 2.73. So basically 1 plus root 3 is greater than my e. That means my value of x is somewhere here. If it is somewhere here, that means the output that I would always get, my output would always be greater than 1. This is my output. This would always be greater than 1. And if my output is always greater than 1, it cannot be equal to sin x, because sin x ranges from minus 1 to 1, right? So this can never be possible, because this would give us value greater than 1. So this is never possible. That means there is no solutions for this equation. There is no solution for this equation. There is no such value of x that will satisfy this equation. So this is how you solve the equation. So again, these graphs of e to the power x and logarithmic graphs we've studied in our functions chapter. So I hope you all remember it. And based on that, we solve this question. So that was all about the questions in this chapter. Again, as I told you, very short chapter. We do not need to look into more different types of questions, because all the different types of questions that JEE could have asked, I've given to you either in the practice way or in the JEE Mains previous year. So definitely a chapter where you should remember the formulas and practice a lot. That's all. Thank you.